This is the first of a series of videos of reviewing square roots. So the videos that will be included will include these 5 different sections. The first one that we'll do now is simplifying square roots, and then we'll have one multiplying square roots, adding, subtracting square roots, graphing square roots, and domain and range of square roots. The last one will necessitate knowledge of functions, and if you need to review that more, there's a similar series of videos on review of functions. So first, let's review what a square root is real quickly in a real informal manner. We say that the square root of 36 is 6. And the reason we say that is because the square root of 36 is a number which times itself will give you 36. So more generally, the square root of x is defined such that the square root of x times the square root of x will equal to x, in the same way that the square root of 36 times the square root of 36 is equal to 36. Now, that number sometimes exists, sometimes is easily found, and sometimes is an irrational number. So we need to first come up with the idea about when it exists. We say that the square root of x exists as a real number if and only if x is greater than or equal to 0. And we say that it does not exist if x is less than 0. Now, there is a whole field of complex numbers, or you may have studied it as imaginary numbers, which allow for the square root of a negative number, but that is not what we're doing here. When we talk about the square root of review, we're really talking about the square root review of real numbers. The first concept we need to come up with is what are called perfect squares. And the easiest way to do perfect squares is to do examples. The perfect squares, the first 12 or so are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144, and 169. These are the perfect squares. The reason it's perfect square is because 1 squared is 1, 2 squared is 4, 3 squared is 9, 6 squared is 36, etc. And we use that. There are obviously many more. There's actually an infinite number of perfect squares. But you want to memorize these first 12 or 13 in order to be able to simplify square roots. Now, if you have a square root of a number, it may be simplified, and let's say what we say when we say simplified. Let's say you have the square root of 80. To simplify the square root of 80, what you do is you need to take 80, you need to find 2 numbers that multiply to 80, one of which is a perfect square. So you find 2 numbers that multiply to 80, and one of them must be a perfect square, or both. So that's the reason we need to memorize the different perfect squares. If we look, 8 times 10 is equal to the square root of 80, but 8 is not a perfect square. So let's look at our perfect squares real quick. See if 80 goes into any of them. 4 does, it's 4 and 20, and actually 16 does, 16 and 5. So if we simplify this into the square root of 16, the square root of 5, then the square root of 16 simplifies. The square root of 16 is 4, so we get the answer 4 square root of 5. So we get the idea of what we mean by simplify When we say simplify a square root, we mean to rewrite it so that the number that's inside the square root is as small as possible. One thing about simplifying square roots is there's not always just one way of doing it. Let's look at the square root of 80. The square root of 80 we divided into square root of 16, square root of 5. Square root of 16 is 4, so that's 4 square root of 5. You could have, square root of 80, split it up into square root of 4 and square root of 20. Because 4 times 20 is 80, and 4 is a perfect square, so that's 2 square root of 20. And that is simplified, it's just not completely simplified. To completely simplify it, you need to find a number which goes into 20, which is a perfect square. That's 4 and 5 again. That's 2 root 4 root 5. 2 root 5. Since there's a 2 out there already and you take a number out of the square root, you multiply those two together and your final answer is 4 root 5. And that's helpful sometimes when you have a very large number and you're not necessarily sure that what the largest perfect square is. Square root of 320. Obviously that's 4 and 80, which is 2 square root of 80. And then square root of 80 becomes, let's see, that can become 4 and 20 or 16 and 5, either way. If I do it 16 and 5, that's 2 square root of 16 square root of 5. 2 times 4, that's 8 root 5. You would have got the same answer if you would have noticed that 16 goes into 320. That's 16 and 20, so that's 4 root 20. 4 root 20, that becomes 4 and 5 again. That's 8 root 5. Let's do one more example of simplifying square roots. One thing you want to remember about simplifying square roots is that if you have a number like, let's say, 10 square root of 700, let's say 7 and 100, let's see, it's a perfect squares, there's 7 and 100. This becomes a 10, so that's 10 times 10 root 7, which is 100 root 7. If you have a negative out in front, say like minus 5 square root of, let's say you had square root of 420. Now 405, let's say. Oh, actually, no, let's say square root of 400. Minus 5 square root of 400. Square root of 400 is square root of 4 square root of 100. That's minus 5. That becomes a 2, and that becomes a 10. In this case, square root of 400 is a perfect square as well. And even if we didn't notice that when we broke it up into 4 and 100, both of those are perfect squares. So we get 2 times 10, which is 20 times 5, which is minus 100. That's how you simplify square roots. The next video will be part 2, and that'll be on multiplying square roots.